Hello, my name is Jingyu Liu. My student ID is Z551192. My experiment is understanding the solar system. First of all, what are the Kepler's laws? Kepler's laws are three laws proposed by astronomer Johannes Kepler that describe the motion of planets around the Sun. They are the basic laws of planetary motion. First law is that the orbits of planets around the Sun are all ellipses, and the Sun is at a fourth of every ellipse. The second law is that the area swept by the line between planet and the Sun in equal time is equal. Third law is that the square of the period of a planet's revolution around the Sun is proportional to the cube of the semi-major ellipses of its orbit. About the question 9, for A, yes, the planets will move relatively slightly during the Moon's revolution. For B, in problem 1, 4, and 5, when the planet orbits the Sun, the center of mass of the planet and the Sun are between the centers of mass of the Sun and the planet. For question 1, since the Sun is heavier than Earth and the difference is large, the center of mass is closer to the Sun and is inside the Sun. The difference is that question 4 changes the mass of the planet. When the mass increases, the center of mass will be closer to the center of mass of the planet. When the mass decreases, the center of mass will be closer to the center of mass of the Sun. Question 5 changes the magnitude of the planet's speed. The speed itself will not change the position of the center of mass, but the change in speed changes the orbit. So the position of the center of mass will move away from the center of mass of the Sun as the distance between the two increases. For C, the difference is that the center of mass between the Earth and the Moon is outside the Earth. For question 11, the distance between the markers is 0.5 AU because the distance between the Sun and the Earth is 1 AU. The results of question 14 are shown in this table. After calculation, the cube of planet distance divided by the square of orbital period are approximately the same value, which shows that the experimental results are consistent with Kepler's law. For the question 15a, Mercury has the fastest linear velocity in the solar system and is closest to the Sun. Neptune has the slowest linear velocity in the solar system and is farthest from the Sun. For the question C, the reason is that the linear velocity is negatively correlated with the radius. According to the Kepler's third law, in the nearly secure orbit centered on the Sun, the radius of the cube of the radius 2, the square of the period, is a constant. So we can write it like this. With the P is a period, R is radius, K is a constant coefficient. The period is related to the linear velocity and the radius at V equal to 2 pi r divided by P. So we can get the formula for the linear velocity and the orbital radius like this. Thus, we can get that the linear velocity is negatively correlated with the radius. About the question 16 from this experiment, I learned about the laws governing the operation of the solar system. I learned about Kepler's laws and its relationship between speed, mass, and orbital radius in the process of real or simulated planetary motion. And I recognized some laws such as when some planets orbit the Sun, the planet closest to the Sun has the slowest linear velocity. And when the planet orbits, star will also practice some tiny movement, which are some interesting laws. At the same time, I recognized that we should learn astronomy through practice. And this experiment also increased my interest in astronomy.